Welcome to Mr. Anderson's physics tutorials. Today we're going to talk about Newton's three laws and we're going to go over free body diagrams. So, first off, what are Newton's three laws? Okay. Well, Newton's first law is known as the Law of Inertia. The Law of Inertia essentially means that an object that is still will remain still until it has a force that hits it, and then it'll start to move. Or if an object is in motion, it remains in motion until it has a force that counteracts it to stop it or pushes it even more, causing it to go even further in that current velocity. In other words, it causes it to go from a constant velocity to a state of acceleration. Okay. Now, what's important here is, and what's often overlooked, is what these words mean. So we say things like velocity and acceleration all the time, but I don't think we actually understand what they are. Velocity is actually just referring to speed, and you can think of speed, think of a car that is just simply miles per hour. Acceleration, though, is the change in speed. So it's how the speed changes. So when you hit the gas and you start to go faster, you're changing your speed, and that change of speed, the change in speed, is known as acceleration. Okay, so this is a subtlety that's important to realize. In any case, this is Newton's first law. Okay, so Newton's second law can be summarized as force equals mass times acceleration. Okay, now what's important to realize is that if the force remains the same, okay, what that means is that your mass, if I change the mass, let's say I increase the mass, what that means about acceleration is that acceleration thus has to decrease. And by whatever I change the mass, the acceleration has to change in the opposite direction. So for example, if I one second here, let me change my color. If I double my mass, then that means my acceleration has to be half. If I tripled my mass, that would mean my acceleration would be a third. Okay? It will always remain that way in regards to if the force has to remain the same. However, if, on the other hand, I change my force, this has a direct effect on both mass and acceleration. So if I increase my force, that means either the mass or the acceleration would also change, right? And this is easy to understand if you think of numbers. So if my force is increasing, if let's say I have a problem that gives me a force of 4, and my mass is 1 and my acceleration is 4, then what does that mean if I increase the mass to 8? Well, that either means I either double my mass or I have to double my acceleration, right? If I double the mass, this would be 2 times 4, which is 8. And if I doubled my acceleration, this would be 8 times 1, which is 8. In either case, that's all that's going on there. So what we say is that the relationship between, let me change the colors again, the relationship between force and, the relationship between mass and acceleration, these guys have what's called an inverse relationship. Okay, an inverse just means if one goes up, the other one goes down. If one goes down, the other one goes up. The relationship between force in either mass or acceleration is what's called a direct relationship, which means as one goes up, the other one has to go up. So as I increase force, I have to increase either mass or acceleration increases. And typically is the case, the mass stays the same. And if we think about that typically makes sense, right? So if we're pushing something, if you're in a car, right, and you accelerate, that means when you hit something, you're going to have a greater force. But your car usually weighs the same, right? It doesn't, unless you, of course, you're eating too many hamburgers or tacos or whatever. Okay. Next, we have Newton's third law. And so what's Newton's third law? Newton's third law is simply that for every action, there is an equal and opposite reaction. So what do I mean by this? Well, what this means is that if you're going towards something, okay, when you hit that something, whatever force you're going at, when it coincides, it will have an opposite reaction with the same amount of force. Okay, this means that if you have a fly, and this was on the packet, a fly going towards a truck, I definitely have awesome artistic talent. When they collide, when these two collide, the force of the truck is actually going to, and the force of the fly will be the same. In other words, they'll have, when they collide, they'll have equal and opposite reactions. Okay, believe it or not. And this is why actually the fly becomes obliterated, because the force going in the other direction is so much that it tends to obliterate the fly. But Newton's third law is simply that for every action, there's an equal and opposite reaction. In the next video, I'm going to illustrate free body diagrams. So after you're done watching this, please watch the next video on free body diagrams.